All right, let's look at another rule that we haven't covered yet, which is the derivative of natural log functions. So if we have a natural derivative of a natural log x, then the derivative is 1 over x. So very simple, it's always 1 over x. Now, if that inside function is a u, and we're taking derivative with respect to x, and we say that u is a differentiable function of x, so that means u is a differentiable function of x. You can take the derivative with respect to x, meaning there's some x inside of u. Then when you take the derivative, you have to take the derivative of the log, which is 1 over that thing, whatever that thing is, and then times du dx. Okay? Okay, let's try this one. So for example, y is equal to natural log 2x. So then the derivative of y is equal to 1 over whatever that thing is, and then this is 2x. And then chain rule, derivative of 2x, which is 2. So this is 1 over x. Whoops, 1 over x. Okay, let's have you try number 2. Y equals natural log x squared plus 1. All right, 2x over x squared plus 1. Okay, let's try this one. This requires a product rule. And then here is the answer. All right, last question. Go ahead and try this one. All right, go ahead and check your answer. Okay, now that we know how to take log derivatives or natural log derivatives, let's look at how it's useful. Let's look at this problem. So you can see that this is quite complicated, right? If you were to take the derivative of this, you would have to do 1 over this whole thing. And this whole thing requires a product rule with a chain rule and a quotient rule and the chain rule inside. That is really crazy, and that would take us a very, very long time to solve. So here's a trick on simplifying this function. So we have to kind of recall your log rules. So if you are not, remembering your log rules, here's a really quick recap. Natural log of xy is the same thing as natural log x plus natural log y, right? If we have something multiplied together, it's the same as splitting the natural log into two natural logs that are added together. And then the other rule was if it's x over y, then it's the same as natural log x minus natural log y. And then another rule, natural log x squared is the same as 2 natural log x. So hopefully you're kind of remembering these. And obviously natural log 1 is 0. I think you probably recalled your memory on this one by now. These are some really quick rules to remember. Obviously there were a lot more. If you don't remember, you probably want to look at your notes from Algebra 2 or Pre-Calc. So using those ideas, what we can do is the whole idea is let's split out this whole natural log thing, because you can see that we have a multiply here, we have an exponent here, and then we have a divide. So we can actually split out this whole function into natural log of x plus natural log of x squared plus 1 squared. And why did I do that? Because there's a multiply here, so I can change that to a plus. And then minus natural log square root of 2x cubed plus, minus 1. Okay. Be careful with the multiply and then divide. The order matters, and the order that you think about it matters. All right, the other thing I said was we can change the exponent and then put it in the front, and then you can think of the square root as a 1/2 and then put it in the front. So we have natural log x plus 2 natural log x squared plus 1 minus 1/2 natural log 2x squared, cubed, minus 1. Okay, so remember, don't simplify anymore. Natural log x squared plus 1 is not natural log x squared plus natural log 1. This is not a distributive property. This does not work. So this is as much as you can do. Remember, the rule says when you multiply, then you can change it to an add, not so if it's like this, there's nothing you can do. Okay? All right, so remember this is still all equal to y. So if we're trying to figure out the derivative of y, what we now need to do is just take the derivative of y and then take the derivative from each of those terms. So now it's much easier to do. 1 over x plus 2, and then the derivative, chain rule, minus 1/2 1 over this whole thing, chain rule. Okay. 1 over x plus 4x over x squared plus 1 minus 3x squared over 2 times 2x cubed minus 1. All right, that's as much as I want to simplify any further. It's not going to make the equation any better. All right. Let's see. Let's have you try one on your own. This one is a little bit longer. The trick on this one is if you kind of compare this one to the previous problem, you see that both of them are very complicated, but the key difference is this one has a natural log, the other one, the new one, does not. What does that mean? That means when it has a natural log, we can just basically kind of split it up as we would, like this, and then take the derivative. Even though it is a little bit tricky, but still, the natural log kind of made it nice. This new question does not have a natural log. So if we want to actually incorporate this trick of using natural log, then we need to actually apply natural log on both sides. That means when you take the derivative on both sides, you have to remember that you're actually taking the derivative on the left with a natural log y, which means that you have to go back and fix it later. Okay, so let's go ahead and kind of do as much as we can together. So you're going to first split this up into many different natural logs by using the log rules. So go ahead and do that, and then we'll finish the problem together. All right, so we have gotten to this point. Just a little bit of caution. So you see how in here I put parentheses around x squared plus 1. You really need to do that. If you just put this, you're going to confuse yourself. Is x squared plus 1 inside the natural log, or is it just x squared inside the natural log? And then, that derivative is very different. So you have to be very careful and put parentheses. All right, so now we need to take the derivative of both sides. So the derivative of natural log y is 1 over y. And chain rule, so there is a y prime, kind of remember the implicit differentiation. And then on the right-hand side, just take the derivative. So 3 over 4 times 1 over x plus 1/2 times 1 over 2x squared plus 1 times 2x minus 5 times 1 over 3x plus 2 times 3. All right, let's simplify the right-hand side as much as possible. Probably there's not much we can do. All right, so this is all equal to y prime over y. So don't forget the left-hand side. This is the tricky part. When the problem didn't start with natural log and you want to use the natural log differentiation, you would need to apply natural log on both sides, which means when you take the derivative of the left-hand side, it is actually a chain rule. So be careful of that. All right, so now if we want to find y prime, we need to multiply everything by y. And then what is y? Y is this thing from the very, very beginning. So I'm just going to rewrite the y part from the very beginning of the question. And that is my derivative. Now let's talk about a different technique. So this is called a variable-based variable exponent power rule. So when you have something like this, y equals x to the square root x. So you see how here there is an exponent, but the exponent is not a number. That means you cannot just say differentiate and then you just bring down this and then this thing minus 1. This does not work. This is not a power rule. So why does this not work? Very simply, when you're doing a power rule, it works because you're just reducing the power by 1. That is, you're reducing the power by 1 from something that was constant. Now that x is a variable, that means x is going to keep changing, right? X is going to change to whatever x is changing to. And so if x is not constant, then you're saying, oh, just subtract that power, which is x, by 1. Well, what if x keeps changing? Then your function keeps fluctuating, and you just cannot figure out what the derivative is. So you cannot actually do that. So please, please, please remember that if x is in the exponent, you cannot do that. So what should we do? We're going to change the problem a little bit so that it's easier for us to solve. All right, so now let's take a look at this question. We need to remember to take to utilize the log rule, which can help us bring down this exponent. So if we apply log on both sides, natural log y is equal to square root x natural log x. And now it's a question that we can actually solve. So go ahead and solve this problem. And remember, on the left-hand side, you're taking the derivative of natural log y, which means if you want to find y prime, you gotta multiply y back later. Okay, once you take the derivative, you get to this point, and the last thing is we need to find y prime, which is multiply everything by y. I'm gonna put all that in the front. Then multiply by y. I'm not sure if we can really simplify this anymore. Maybe we can combine these together, but other than that, there's not much we can do to make this much simpler. All right, let's have you guys practice one. Differentiate this one, don't simplify. All right, so again, if we have a variable base, variable exponent, you need to bring that exponent down by taking the log on both sides, natural log on both sides. So you can bring it down, and then you can apply the differentiation rule. So go ahead and try this one. All right, this is probably as much as you can do unless you want to change sine over cosine into tangent. All right, let's try one last one. All right, go ahead and check your answer. And that's how you utilize natural log to help you solve some questions.